Hi students, today we will go with a 3 cable problem, that is 3 cables are inserted with this different eccentricity. Here that is a rectangular beam is given and 3 cables, that is 1, 2, 3 respectively, and different it is cables. First one is a parabolic cable with 50 mm below the centroidal axis at central span and 50 mm above the centroidal axis at support. I have written like this, so you can see it. So 50 mm at the center span and 50 mm from here to here, 50 mm above the neutral axis, that is they have given in the first cable for the, and second cable here, cable with the parabolic 0 eccentricity at support and 50 mm eccentricity at mid span. Here you can see at support it is 0 eccentricity and at mid span it is 50 eccentricity. So for the second cable also eccentricity is 50 at mid span, and for the last cable, third cable, here they have written with the straight with the uniform eccentricity, that is throughout this it is straight tendon is used cable. So here it is a 50 mm eccentricity they are given. Okay, straight cable with the 50 mm eccentricity is given. So throughout it is at support as well as at mid span, and span length is given as 10 mm. So I written the cable's profile cross section at support. This diagram showing cross section at support section. So these are the few datas, given datas you can list out. So I will not do that one. Okay. So next we will move out. That is the first loss you have to calculate in the loss of Prestress. That is loss is equal to M into Fc. That is a regular formula, loss due to elastic deformation. If it is a, that is Fc is equal to, here Fc is equal to P by A, P into E divided by I into E minus M by I into E. Live load is not given in this problem also, so you can neglect, you can zero it. But here in this case, if there are a few cables are used, then you have to make this as first cable eccentricity, P into E as first cable eccentricity, and this is immediate next cable eccentricity. You have to write it. So here that is 2 eccentricities are there. So at the mid span as well as at support is different eccentricities are there. So I'll be going with this one, Fc support, that is Fc at support I am calculating P by A plus P into E divided by I into E. So P is 240 into 10 raised to 3 divided by 100 into 300, that is the area. 240 into 10 raised to 3 is a P value, and E is eccentricity of the first cable at support. So I will be going with this one diagram, eccentricity for the first cable. So this is a first cable that is above neutral axis, so you have to take it as minus sign. Above the neutral axis, whatever eccentricity is there, that has to be taken as minus. So it will be minus 50, and at the support for the second, immediate next is after the first, that is second cable lies. So you have to take it as eccentricity of the second cable at the support is 0. So E will become 0, this one, second cable, immediate next. So Fc support is equal to 8 Newton per mm square, it happens. And next that is at the mid span. Similarly, you have to calculate, that is P by A, P into E divided by multiply by E. So you will be getting as E1 and E2, that is both cables. So first and second cable is at the mid span, eccentricity is the same. You can see here the diagram. So both all 3 cables at mid span is same. So you will be substituting same thing for the both E's here as you done in the earlier problem. So F at mid span you are getting here. If you draw a diagram for the stress distribution diagram at mid support as well as at mid span, you will be getting like parabolic shape because the cable profile is parabolic. So I want at the mid of these two. So I have to calculate Fc average. So 8 is this one is a constant, but I want this extra portion, that is here I can easily calculate here to here, but this value I have to calculate. For that I have to do, I have a parabolic equation for to calculate at the center, that is 2/3 of this value here to here. Total this value here to here you have to calculate, that is nothing but 10.67 minus 8. So you'll be getting as that is 9.78 average. Now you can calculate loss in cable 1, that is M into FC. You have to calculate. So this is a loss in first cable. Next, corresponding you have to go with the second cable. So FC support, again you have to calculate P by A, P into E of corresponding. So it will be corresponding means E2 it becomes, and this one is immediate next is E3. So E2 at support is 0. At support, second cable, you can see it here, there is 0 here. 3 is 50 at support. So I will be substituting that one here 50. Okay. So FC at support you will be getting as 8 Newton per mm square again. Next we will be moving, that is FC at a mid span. It will be 50-50, so it is 10.67. So finally the parabolic equation you will be getting, finally by solving you will be getting same value again 58.68. In the last cable, that is third cable, here you have to be some conscious here, P by A plus P by E I, and this one is corresponding cable, that is E3, and immediate next cable, that means which one will come? Now you have to take E1 immediate next, 1 2 3, it is like that. So 3 is over, and again it has to be taken as 1. So E3 value is, or it is vice versa, you can write it. Here you write it as 50 and this one is minus 50, this one has to be written here. So FC is equal to 5.3 Newton per mm square you will be getting. Midspan, again it is both eccentricity will be giving as 50 and 50. Now parabolic equation you solve it, and as it is continuing here. And now if you consider here, once all these calculations, loss in first cable, second cable, third cable is over, then you have to do it in this fashion. When cable 1 is tensioned and anchored, first you have to stretch first cable here and anchored. So in that cable, how much loss is there? There is no loss, because it is, we studied at the beginning only, if only one cable is there, then no loss in the cable. So loss of elastic deformation will be 0, because of the theory we studied. So next, that is when the cable 2 is tensioned, first was anchored already, second one is tensioned and anchored, at that time loss in the second cable will be 0. Remember, second cable it will be 0, but in the first cable it will be, loss will be there, that is 58.88. Next, that is when the cable 3 is tensioned and anchored, now loss in the cable 3 will be 0, but in another 2 there is a loss. Okay, that finally first cables whatever is there, cable 1, that has to be added here, 0 plus 58, so this much, total it and divided by 3 you have to do it, and percentages individually you can do it. Okay, thank you.